So this is my video on inverse trig functions. Inverse trig functions you learned during our trigonometric classes, right? What it does is really the inverse of the trig. So for example, if you have, say, if somebody wants you to find, uh, say sine inverse of 1/2, you are asking, is there an angle actually whose sine is equal to 1/2? So you're asking the reverse question, is there an angle whose sine is equal to 1/2? And we know that that angle is pi over 6. Right. Of course, there are several angles in the first quadrant, the second quadrant, and then again in the fifth quadrant when come back one circle. But you have a convention that you always select the angle between negative pi over 2 and positive pi over 2. But that is trigonometry. So same deal goes for cosine and tangent. Except cosine, you select the angle between 0 and pi, right? And in tangent, inverse, you select the angle between negative pi over 2 and positive pi over 2. So I would request you to revise your trigonometry if you have concerns about the definition. But what we are going to do is we are going to do calculus on these functions. So first of all, we take the function y equals sine inverse x, and we want to find what the derivative is. And in order to do that, first of all, let's go to the definition. So if y is equal to sine inverse x, so we're really asking what is the angle whose sine is x. So if that angle is y, then we know that the sine of y is actually equal to x. So if y equals sine inverse x, sine of y is equal to x. Same way, if y equals tangent inverse x, tangent of y is equal to x. If y is equal to cosine inverse of x, then cosine y is equal to x. I'll do it for sine inverse so that the argument will follow the same for the other inverse trig functions. So now we have an equation in x and y. We implicit differentiate both sides. So when you implicit differentiate left side, you get the derivative of sine y is equal to cosine y, but because it's a y term, you multiply by what? Dy over dx. When you go to the right side, the derivative of x is 1. So now you want to solve for dy over dx, which is 1 over cosine y, which is great for an answer, but you want the answer. You started with x, so you want the answer to have x, so you need to convert cosine y into something with x. Well, that can be done if you use Pythagorean. Cosine squared y is equal to 1 minus sine squared y, because sine squared y plus cosine squared y is equal to 1. Cosine squared y is equal to 1 minus sine squared y. So if you take the square root, then you get cosine y is equal to square root 1 minus sine squared y. But we know that sine y is equal to x. So then this is the same as 1 over square root 1 minus sine y is x. So 1 minus x squared. So we got now the derivative using x. So that is our answer. All right. So if y is equal to sine inverse x into sine of x, the derivative is equal to 1 over square root 1 minus x squared. So using a similar argument, we can show that the derivative of inverse cosine of x is equal to negative 1 over square root 1 minus x squared, and the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. Note that there is no square root with the tangent. Okay. So let's do an example. So we start with something like y is equal to inverse sine of x squared. You want to find the derivative. So we use chain rule. So first of all, you see the junk inside as one quantity. So you don't see that when you differentiate. So the derivative would be 1 minus. So you go up here. It's 1 over square root 1 minus whatever the junk is squared. Okay. So it's 1 over 1 minus. So what is here? So it's x squared. So it's really x squared squared. So let me maybe write it like that. It's x squared. But we know that x squared is equal to x to the 4. So in the end, this turns out to be 2x divided by square root of 1 minus x to the 4. Okay, so that's the uh, okay, good. So it's 2x over 1 minus x squared. So once again, so what you do is you take this as one quantity, so it's 1 over 1 minus x is junk, so it's junk squared, so junk is x squared here, so it's x squared squared, and then you go inside and you see a 2x, and you want to multiply by the 2x, you get 2x multiplied by 2x, so it's 2x over 1 minus x to the 4. How about this one? So now you have two pieces here, so you need to do product rule, so it's right one, x squared times the derivative of this, the derivative of tangent inverse x, which is what? Which you know is equal to 1 over 1 plus x squared. So we have x squared times the derivative of tangent inverse x is this, plus right 2, which is tangent inverse x times the derivative of x squared is 2x. So that's the answer for that. Let's do something like this. So now we are trying to integrate. So we look for an integral which looks like this. So we look at the three things. We look at this, and we look at this, and we look at this. Okay. So the derivative should look like one of this. So out of these three, what is this most closest to? Well, you can see that it is actually closest to the sine inverse. But if you look at the sine inverse sine, the derivative, it has 1 over square root 1 minus some quantity squared. This doesn't exactly look like that. You have 1 is there, 1 minus is there, but we need to write this as one quantity squared. So 9x squared is the same as 3x quantity squared. So that's the first thing that you look. At the same time, you have to make sure that this is one quantity, right? Okay, so one variable. So the way to do that, you put the substitution equals 3x. And when you do that, right, then you get, of course, you get like du over dx is actually 3. So which means dx is equal to du divided by 3. So if you put that, you get like the 3 at the bottom goes up at 1/3, and then you have 1 over square root 1 minus 3x is actually u. Okay, so then you get u quantity squared du, and we know that this actually is the derivative of the inverse sine of x. Remember, the inverse sine of x derivative is that. So this would be, so the entire derivative of this or the integral of that should be the inverse sine of u. So the answer is 1/3 inverse sine of u plus c, but you need to plug in for what, substitute back u, but u is equal to 3x, right? Okay, so so u is equal to 3x, so it should be so you just plug that in and this is your answer. So that's how you do a basic integral on that. And so you want to make your integral look like one of the known things, the derivatives of the okay, so that's the key part of that, right? So that's it for this video. Thank you for watching.